This is the first video for electrostatics. This one will be on electric fields and in particular the directions of the electric field. So I will start off by taking a positive charge and putting it right here. And the way the electric field is defined is the direction a positive test charge will accelerate. So what that means is this here that I'm holding here, this orange ball, is my positive test charge. If I were to drop it right here, it would accelerate to the right. Therefore, the direction of the electric field at this point, due to this charge, is to the right. If I take another test charge and I put it off on the left side, it will accelerate away from the positive charge, as well as here and here. And as I keep dropping these test charges, we begin to see a pattern emerging. So the electric field around a positive charge itself is everywhere pointing away. I do want to note one thing. I'm going to take a look at this charge right here, this test charge. We see how strong it is. It is pointing down away from the positive charge. If I put a second one right here, we see it's still pointing down, but it's not as strong. So the farther away you get from your charge, the weaker the field will get. Now if I take a negative charge and I put a particle here, this is my test charge. Remember, the test charge is positive. It should accelerate towards the negative charge. So what we're going to see something very similar to the previous example with the positive charge, except now all the arrows are pointing inwards. And again, if I drop a charge down here, we see that it still points up, but it is weaker than the one here. Now it gets tricky. What happens if I put two particles, one positive, one negative? Out here, and it should be noted that both of these charges have the same magnitude. So when I look at this test charge right here, it is significantly closer to the negative, so it's going to feel much bigger impact from the negative. It is attracted to the negative, so the field would be to the left. Although the positive charge does create a field to the right out here, this negative charge creates a stronger field to the left. And likewise, if I put this charge here, we will see it too will be repelled by the positive. The same can be said above and below these charges. In the middle, what we will notice is if I drop a sensor right here in the middle, positive test charge, the positive particle on the left would push it to the right. The negative particle on the right side would pull it to the right as well. So we get a very, very strong field to the right. If I drop it here, both the positive and negative charge will want to pull it to the right. The positive charge will push it down, the negative charge will pull it up. So we see both above and below the middle, the field is almost to the right. Okay. So let's take a look at what the fields actually look like in a little bit more detail. These notes can be found on Blackboard. So we have a positive charge. We see the field lines are all radiating away from the positive charge. The negative charge by itself, it looks the same as it does with the positive charge, except your arrows are all pointing inwards. A positively charged particle would want to accelerate in. If I take a look at the example I just showed you on the diagram, where you had the positive charge on the left and the negative charge on the right, you get field lines on the outsides that are mostly just affected by the charge it's closest to. Then, on the inside, you get very strong fields pointing towards a negative charge. Last one to look at. If the charges are the same sign, and they're set up like they were up here, you can see on the outsides not a whole lot is different than was before, but on the inside what you're going to have is you're going to have an effect where they cancel out. Exactly in the middle between these two charges, the particle on the left is trying to push it to the right, and the particle on the right is trying to push it to the left, and as a consequence nothing happens to it. It just stays there. Well, that's all I have for you, so thank you for watching.